Hello, welcome to this new video. Today, as part of my training, we're going to solve this case of last year's Excel World Championship by Dermot himself, which is called Othello, which is a board game in which you need to place basically your items that could be black or white into this board. There are rules basically to determine whether you are going to win on the opponent's item. Uh, there should be quite simple, so you cannot place, of course, on top of existing items. And in order to win the items of the opponent, um, you need to like create a line, so vertically, horizontally, or diagonally, which starts with your color, then as the colors of the opponent, and then ends up with a color of yours. So, for example, uh, it says the position is not empty, sorry, is empty. Adding the new piece completes a straight line in one direction where both ends are a piece of color just played, and all the squares in between are of the opponent's color, no blanks. After the move, all the pieces of the opponent's color on the lines described in step 2 are changed to the player's colors. Okay, let's see what we have. So, for each of these boards, how many black and white pieces in total are there on the board? Um, Pieces in total. So is this just a count A of this? No. Why? Um, okay, let's see. Count ifs of this. This. Uh, Lock plus the same thing with a white one. Okay, maybe let's call this black and let's call this white. Black and white. Okay. Uh, and so level one is done. How many black pieces are on the board? Okay, that's a no-brainer. It's just this, and that's it. For each of these boards, can white play a valid move in any given position by placing the white piece into the designated cell? Yes or no? Well, this will be very nice to tackle with a random approach, but let's solve it the right way. For each of these boards, how many pieces can white capture by playing into the designated cells? You can assume this is a valid move. Of all the valid positions, white can play for the next move, which will capture the most piece. Okay, let's build the model. So we have the solve. We have example 3. Actually, is example 3a. Okay, let's X lookup. So B and basically I to BT. Okay. Um, hmm. Um, mm, 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 mm. Let's try to reproduce the board. Um, so basically the board will be this and this. Um, and I can say index of this lock matching this lock the row and this lock the column here 0 actually will be matching on the columns Uh, okay. Let's hope this is right. Okay. I'm asked for G91. Uh, so GG. Okay, so A1. Basically, you can quickly see that this is not a valid move if you need to place a white piece because here you don't have a white piece ending. This is why it's not good. This is empty, and so it is no. But we need to make this dynamic. So what we could do is to build arrays in every possible direction of this thing. So we'll be horizontally to the right and to the left, vertically down and up, and then diagonally up right, down left, up left. Okay, so let's say that mm, horizontally, we have, say, row offset and column offset. So horizontally, um, let's say to the right, we have an offset of 0, and we have a column offset of 1. So this will be plus 1. We have a maximum of 8. So, okay, plus the cell itself, which is always one check. So, actually, I need 7 of these. And this will be 0. So what I'm going to say is basically hmm, what if I do this, this, this is still working, okay. I want basically this to move to be placed exactly here. So this is A1 for real. Um, so my starting cell is this. Um, so indirect of this gives me what is there. And so if and this not black, this not white is 1, otherwise it's 0 because this needs to be empty. So the first check goes well. What I can do here, it's the offset of indirect of this, those rows and those columns. So basically, I'm saying that one to the right, this is empty, then I have black, white, white, black, empty, black. Can white play valid move? How many pieces can white capture? White can play. So I need to solve every time for white. So I need the logic. The logic will be that the first cell needs to be of the opposite color. So if this equals black, I have 1, otherwise I have 0. Okay. Then I will need to consider once until I have still white positions, sorry, black positions. Uh, okay, so let's say this is equal to this plus if this equals black 1, otherwise 0. Uh, okay, so 1, say and this is black and the previous one is black. Okay, so in this case I have nothing. And then I need the white to, let's say, close the loop. Um, and so I need to say mm, that if the previous one is black, no, actually I don't like this. I don't like this one because I want this to be 0 if this is not black. So this is one if this is black. Then I have another one if the previous one is black and then this is black. And then I want to say that and the previous one is black and the current one is white, then I have, let's say, close, otherwise I have 0. Okay, so this is close, but this is not even open. So I will add the previous one is black. This is actually 1 and okay. Okay, so not is error match C in this thing here. Minus minus. Okay, so basically I'm saying this is not a good, a valid, let's say, uh, combination for white. Then in this case I will have horizontal left. I will be minus one. Okay, and so this is not good. Now I need the vertical. So for vertical down, I will have a bunch of zeros, and I will have basically the row going up. So this is having the ones, but is not closing the loop, so this is not valid. And then I will have vertical up, which is basically the opposite. Okay. Then I will have diagonals. Oops. So diagonal up right. Let's copy 4 of these, 2, 3, and 4. Okay. Down right, down left, and up left. So upright will be row, okay, going in minus direction, and those ones actually will be incrementing like this. Down right will be both of those going incrementally. Down left will be the row incrementing and the column going backwards. And then up left will be both of them going backwards, actually. So the row, yes, because up and this is left. Okay. So the only applicable one is the down right in this case because I'm in cell A1. Let's see. So white, white, black, white, white. White, white, black, white, white, which is not valid, by the way. And so, what if I put this here and say that I need an end of all this stuff? Okay, minus, minus. Okay, so the answer will be no to this, but we should have a yes in example 3b. Let's see if this works. No, because I don't need the end actually. I need the or of this. I need the or of this times this. Okay, so basically horizontal right is 1 and all the other ones is also down right 1 is good. So horizontal right is okay, it starts from B1. Okay, so here, so black, white, so white, black, white is good. White, what is also good? Currently for this model, down right, because we have black, white. Okay, so yes, apparently is correct. Let's try to scale it. So sequence of 100. If this equals 1, yes, otherwise no. Let's see. So 31 to 50. Actually, no, H3 is not right. 34. So H3, which is empty by the way. Horizontal left. Uh, okay, I understood why. Because I need to say that the previous one is black, but also this equals 1. Otherwise, it's not good. Because otherwise the sequence would have started too late. Let's update. So 31 to 50. Okay, this was a tricky one to spot actually. Level 4 for each of these boards, how many pieces can white capture by playing into the designated cells? You can assume this is a valid move. At this point, I think this is quite simple. Consider the model I've built because I will just say countifs of this 1 times oof, times the valid move. Okay, so 3 plus 2. So yes, 5 pieces. Uh, so will be the sum of this thing here. Okay, so this, let's scale 51 to 70 probably. Yes. Of all the valid position, white can play for the next move, which will capture the most pieces. Uh, okay. Mm, actually, is this a two-way data table? Because I will need to apply this as well to scale basically with this. Um, so basically calculate how many can I win for every one of those and then take the maximum. I think so. Uh, so the answer would be the cell itself in which I'm going to play. Okay, let's say this is A1. Let's say I want to put this here. No, clearly this was not a good move because I have my wall model in here. Okay, for some reason this crashed. But basically I think I'm done because I need to compute basically the two-way data table. So let's cancel everything. I'm afraid I will need to move on the right. Okay, so let's be here. Okay, so this is one. Let's be the sequence of 30 from 71 because I don't need everything. And the number of items I win is this. Okay. Let's build the data table. So this will be my level and the raw input will be A1. Okay, calculate. And then basically the max of this and then the index of this lock where row is 1 and column is match the max here exit match. So E6 example 5, let's see. Actually example 5 is not computed, so because it's not into this data table. Mm, well, since I have the answers, I'm pretty confident this is right. Let's try to just do it. Actually, it's not right at all. At least not all the answers. Which will capture the most pieces are not possible. So E6. Uh, so E6, it's saying going to capture 12 pieces. Is this 71 actually? Yes. Yes, because this is not a valid move. Mm, times well, time this is the same. So let's calculate again. Uh, okay, now checks out. So yes, I would have spotted this because this is where this was not into the radio buttons to select, so that's good. Yeah, I think there are no bonus questions for this, so I'm done. Is this 1000 actually? Yes, it is. So thanks a lot for watching this video. We'll see you in the next one. Bye.